right? But I mean, there's one geometrical meaning I said the last time. I just didn't have time to go through it. We can talk about it quickly. So the Lorentz transformation is between two frames. Right? Remember, you have a K frame, and then you have a K prime frame. And the K prime frame is moving with a velocity v relative to K along the z direction. That's important because we're only transforming z and t. And so this is along z, z prime, right? And the transformation is just, right? You just write c, k, ct prime and c prime. The transformation is gamma k minus k gt, right? That's the Lorentz transformation. And the x and y coordinates are invariant, at least part of the derivation, we just assume they don't change. So x prime equals to x, y prime equals to y. Okay, so the full transformation actually should be a 4 by 4 matrix, and then you have a column of 4 elements. Anyway, well, just consider this one, and the geometrical meaning is like we transform it to like a rotation, but it's not using sine and cosine, using instead of cos and sinh. So basically, like with gamma, first of course, at least gamma beta defined as beta is we see gamma is 1 over square root of 1 minus beta square. That is a standard notation. So the geometrical meaning, you can get it like gamma is a, instead of cosine, is a cos of some angle. I think that's use the z or something like that. Remember correct. Or zeta, using a zeta. Okay, okay. Now you can figure out what beta is. So the gamma square is cos square, right? Which is the 1 minus beta square, right? So it means you multiply this to the other side, you have cos square zeta 1 minus beta square is 1. But you know that by your function, the hyperbolic function, cos minus sin, cos square minus sin square is equal to 1. So you remember this is like sine square plus cosine, sine square plus cosine square is 1, but for hyperbolic function, this becomes minus, this minus that becomes 1. Then comparing this with that, so you know that the beta square is sin square divided by cos square, which is 10 square. And then also, obviously, you have a gamma beta, so gamma beta, or the square of that, it's just a cos square times t square, which is just sin square. You take the square root, so you can now transform everything. Let's just you want to define that as you see all this becomes this cos theta minus sin theta minus theta cos theta. Right. So the form is similar to a rotation. If you forget about the rotation, you can try to redivide it quickly. So basically, if you consider now instead of this frame transformation, consider rotation. So if you have not just use ordinary x and y. So, and so originally x and y at that same coordinate, you rotate your frame. So you just first give a point. Actually, I should say, give a point first. This x and y actually depends on frame. Or I should say this x unit vector. So this is a x prime unit vector. So you change your coordinate system, right? And so you have a point. Then you can express the point using the origin xy coordinate or x prime y prime coordinate. So you express it with xy. So this would be your x, right? And this would be your y. And this would be your x prime. This length, this is all the origin. This length is x prime. This length is y prime, right? And you rotate the angles, whatever angle is theta, right? Then now you can figure out the relationship between x prime to x prime, y prime to x and y. So like x, so x prime is here, right? So this length is x prime. So you can say this is a projection of x along the x prime direction. So you project it to here. So this is this length. And then there's the y projection on x prime. So you can figure out that you project it on here. So this one plus this projection should give you x prime. So this projection is, so x prime is x times cosine theta, and then y, this length of y project on the x prime, so plus y, right, plus y sine theta. And likewise, y prime is to project x to the y prime axis, but it's in the negative sign, okay? And then project. Oh, no, I wrote it wrong. Right, this is one point. The same point. This is your point you want to see. And projection of y on the y prime axis. But I mean, the idea is that you change zeta to a angle, say whatever you call it, phi theta. Then cos will change to cos theta, cos sinh will change to cosine of theta, right? And sinh a little complicated. Sinh will change to sine. Sin is e to the I, e to the theta minus e to the minus theta divided by 2. So you need the I. So it will be sin sine theta divided by minus. Probably that is what get me in the trouble here. So because usually when you do it like that, you also change the change the IT. Anyway, it getting close to this one. So this is sinh. This is yeah, minus I. And usually when you are t, you got added I in here, so you have I, and there's an I here. But anyway, the analogy is it's like a formula is like a rotation. I mean the detail is I need to figure it out. Usually this is old language. Usually T, I mean the old description of relativity, people like to use imaginary time. If you like using imaginary time, and then the transformation is like rotating in the angle. But you don't have to do that. That's just the the old way of doing things. Nowadays, people not doesn't like as this not as popular that they're using imaginary time, imaginary angle, that kind of thing. Okay, but so that's the geometrical meaning